The dumber people are, the more confident they are that they're not dumb. This, in a nutshell, is the Dunning-Kruger effect, which has been used to explain everything from incompetent politicians to the demise of social media. But is it actually true? The authors of a new paper have reanalyzed the data and they say we've got it all wrong. Actually, confidence is a good predictor for actual performance. Let's have a look. The Dunning-Kruger effect was named after psychologists Justin Kruger and David Dunning, who reported it first in 1999. Their paper opens with the example of MacArthur Wheeler, a bank robber who rubbed lemon juice on his face because he believed it'd make him invisible to security cameras. Dunning and Kruger tested university students on questions in humor, grammar, and logical reasoning. The participants then also had to estimate how well they did. Those in the bottom quarter performed around the 12th percentile on average, but believed they were near the 62nd percentile. Kruger and Dunning therefore argued that the skills needed to perform well were also needed to recognize poor performance. In 2000, they won the Ig Nobel Prize in Psychology. The Dunning-Kruger effect has since been independently reproduced a few times and has entered pop culture. The best summary probably comes from John Cleese.
There's a wonderful bit of research by a guy called David Dunning at Cornell, who's a friend of mine, I'm proud to say, who's pointed out that in order to know how good you are at something requires exactly the same skills as it does to be good at that thing in the first place, which means, and this is terribly funny, that if you're absolutely no good at something at all, then you lack exactly the skills that you need to know that you're absolutely no good at it. And this explains not just Hollywood, but almost the entirety of Fox News.
The authors of the new paper now use the biggest data set we have on the Dunning-Kruger effect, which comes from a 2021 study that also used a set of grammar and logical questions and then asked participants to guess their own score. Let me just show you the data. I'll use the grammar questions, but the data set for the logic questions is very, very similar. The data is this cloud of pale blue dots. On the horizontal axis, you see the actual score, and on the vertical axis, you see the score that people predicted. The diagonal blue dashed line, that would be a perfect correlation if everyone correctly predicted their score. The usual Dunning-Kruger effect shows up in this data by making a linear regression that minimizes the deviation of the prediction. That's the orange line. For the standard Dunning-Kruger effect, one basically asks, if I look at everyone who scored, say, 5, what was their average prediction? What you see is that the people who had a low score on average overestimated how well they did, whereas the people who had a high score on average underestimated themselves. The authors of the new paper now say, look, this is doing it wrong. We're asking the wrong question. We should instead ask, how did the people who predicted a certain performance, say 5 points, actually perform? This is a more reasonable question because people's expectation of themselves is less variable than their actual performance, which might depend on, what they ate last night, what shirt they wear, if it's raining today, and so on. In this case, you make a linear regression that minimizes the deviation of the score, and what you get then is this green line. And this green line tells a completely different story. It says that people on average score less than they thought they would. However, the discrepancy between prediction and score gets larger the better the performance. And even if you leave that aside, it's still the case that the more confident people are, the better they actually score. Okay, interesting, you may say, but wait, how can it be that there are two different best fits to the same data cloud? It's because each of these curves is best in a different way. Loosely speaking, for the standard Dunning-Kruger, you minimize the deviation into the horizontal direction, for the new paper in the vertical direction. You could instead take the mean of both, which would give you this line, and that tells you that the people who score least underrated themselves, whereas the people who score highest overrated themselves. Still, how can it be that there are so many different ways to look at this data? Well, as a physicist, I'd say just look at the data. It basically doesn't have any correlation whatsoever. Why the hell are you fitting any straight line to this? This is why I give this paper, as well as all previous papers on the topic, a 10 out of 10 on the bullshit meter. These are all crappy data analyses. If you draw enough lines through the data, one will eventually confirm that everybody else is an idiot. Let me instead tell you something much more interesting. The original experiments also found that teaching poor performers the relevant reasoning skills improved both their performance and their ability to recognize their earlier mistakes. To me, this means that these tests don't actually measure intelligence, they measure knowledge. There is also the problem that the more people know of the Dunning-Kruger effect, the more they'll revise their prediction of their own knowledge. And if we've learned anything from this, it's that being confidently wrong makes excellent outrage bait. You see, the best thing about the Dunning-Kruger effect is that everyone recognizes it immediately in someone else. Neuroscience is not doing well, not at all. In the past months, we've seen multiple studies from independent groups showing that a large number of studies about the human brain and human behavior are just wrong. I have a brief summary, and then I want to talk about what this means and how it could happen. The most devastating recent paper comes from a group in Germany and was published in Nature Neuroscience. They looked at brain studies which rely on a measurement technique called functional magnetic resonance imaging, fMRI for short, and found that about 40% of these signals simply don't measure what scientists thought they measure. These scans detect changes in blood flow. Scientists assumed that more blood flow means that neurons use more oxygen and fire more. Hence, a larger fMRI signal means more brain activity. But the new study shows that in regions like the brain's default mode network, which is active during daydreaming or memory recall, neurons can become more active just by pulling more oxygen from the blood without increasing blood flow. The researchers figured that out by a study on over 40 healthy volunteers, which also used a more advanced measure for blood oxygen consumption. This means that the results of thousands of studies done in the past decades might be misleading. My default mode network brings up a story from 2009 where researchers placed a deceased Atlantic salmon in an fMRI scanner, presented it with photos of humans in social situations, and detected apparent brain activity due to statistical errors. But wait, it gets worse. Just a month later, a second paper appeared in Nature Neuroscience. The authors looked at the methodological foundations of lesion network mapping. Lesion network mapping investigates patients with brain damage who have the same symptoms. Scientists look for what the damaged places have in common, and if those places are connected to the same wider brain system, they claim that system is responsible for the symptom. But the authors of the new paper reviewed studies for more than 100 neurological and psychiatric conditions and found that many supposedly disease-specific circuits look highly similar across very different disorders. They conclude the current results suggest that a substantial proportion of the presented lesion network mapping are non-specific and may not accurately reflect genuine biological brain networks. It's a bit like finding that all broken cars have tires and concluding that tires cause engine failure, which by all chances would still get citations. Then just in April, a group reported that if you scan people's brains with scanners from different manufacturers, you get different results, and not just a little bit different, but they couldn't replicate the functional brain network map of individuals. Depends on whether you ask Siemens or Philips. These aren't even the only recent studies which flag systematic problems with neuroscience studies. There are so many of these, it's become somewhat of a subfield in its own right. So what the hell is going on? On the one hand, you can say it's a good development. It's the process of science correcting itself. On the other hand, you may ask, and indeed I think you should ask, why the hell is this happening in the first place? And more important still, why does it continue to happen? Because this isn't a new thing. As we saw, this has been going on at least since 2009, and I know that's shocking, but that was more than 15 years ago. It's important because you see, the people who write these critical papers exist, which is great, but it's also clear from the numbers that most of the studies that get published in the areas ignore the known problems with the data collection, the measurement, interpretation, and the analysis, and they'll continue to ignore them for as long as they can get away with it. If you find my science news interesting, please consider supporting me on Patreon or right here on YouTube. And if you already support me, especially those of you in Tier 4 and higher, thank you so much. This channel would not be possible without your help. And unlike some brain signals, your support is very easy to interpret. The problem in neuroscience is extremely similar to what's happened in psychology, where scientists have been squeezing fake results out of underpowered studies with statistical techniques that were widely known to be wrong. This continued for decades, and now every time you turn around, there is yet another supposedly foundational psychology study that could not be replicated. Basically, the entire field of psychology has to start over again. The reason these things happen is that scientists have very strong incentives to ignore these problems so long as they can get their papers published. And scientific publishers have strong incentives to publish papers because that's what they make money from. The tragedy is that this problem isn't remotely new. It's widely known, and yet nothing changes. Which, come to think of it, is also a very good summary of my relationship with my hair. Now, look, I don't want to say all of neuroscience is bullshit, certainly not. The papers I just mentioned are in specific fields related in particular to identifying certain regions or connections in the brain that do one or the other thing, which, it's basically what neuroscience is about, isn't it? All of this makes me think it'll probably be a while until we have our brain interfaces, because it'd be nice if Siemens and Philips can agree whether you actually wanted to post that image on Twitter. The war on artificial intelligence has begun. It's no longer just online arguments about ethical questions concerning the future of humanity or absence of such a future. And it's no longer just people complaining about data centers. We're now seeing the beginning of a new anti-technology movement. Today I have a brief summary and some speculations about what's likely to come next. The case that's attracted the most headlines happened in the early morning of April 10th in San Francisco, when someone threw a Molotov cocktail at the house of Sam Altman, the CEO of OpenAI. According to Altman, the bottle bounced off the house and no one was hurt. Afterwards, the attacker went to the OpenAI headquarters and tried to break the glass doors with a chair. According to security personnel at the site, he said he'd come to burn down the building and kill anyone inside. The United States Department of Justice later said the attacker was a 20-year-old man from Texas, and he wasn't just upset at a ChatGPT bill. According to the court proceedings, he'd authored an anti-AI document in which he expressed the belief that our extinction is impending and AI is the cause, and that he wanted to encourage others to go after AI company executives. This probably didn't come as a surprise to the people at OpenAI. They previously had to shut down offices temporarily last year after an anti-AI activist threatened to come and murder people. But OpenAI isn't the only target. In April, in Indianapolis, City Councilor Ron Gibson said someone fired 13 shots at his home and left a note saying no data centers after Gibson had supported a data center project in his district. In May, 2 teenagers attacked the Islamic Center of San Diego, killing 3 people before killing themselves. They left a manifesto with anti-technology ideology that called for sabotage of the industrial complex and complained about AI slop and a Big Brother surveillance state. Anti-tech activism isn't just an American thing either. In April, an Italian Instagram influencer was arrested in Rome and charged with plotting a series of anti-tech attacks. In November, a group in France tried to set fire to some machinery in an AI data center. The group accused tech firms of links to military technology, surveillance, border control, and the war in Gaza. However, the fire was put out reasonably quickly and the damage was limited. The impact was much larger after an attack just a few months earlier in September 2025, when a different group set fire to 2 power masts in Berlin. The fire caused a large blackout that left tens of thousands of households and businesses without electricity, in some cases for more than 24 hours. An anarchist group claimed responsibility. They said the attack was aimed especially at a big technology park and the companies based there. According to their rationale, research, science, and technology are entangled with war, environmental destruction, and social control. They called the blackout an effective system interruption and urged others to do the same. At about the same time, a different group had set fire to a cable bridge in Berlin. More than 45,000 households and businesses were affected, some for several days. The group claims it's acting in an emergency self-defense and aims to break the dominance of technology. That these incidents are not isolated but part of a trend has not escaped law enforcement authorities. The magazine Wired reports they've obtained documents from a New York intelligence and counterterrorism bureau that warns of widespread upheaval in response to AI adoption in the coming years. Now let's put this into context. Gallup reported in May 2026 that 7 in 10 Americans oppose AI data centers in their local area, with nearly half strongly opposed. Most opposition to AI and data centers is not violent, but if you have upset that many people, it's not surprising that some of them are nutcases who react with violence. At least for now, these anti-AI activists are not members of one organization. For the time being, these are small groups that often have other motives, such as opposing one or the other war, capitalism, or generally anyone they believe has power over anything. But I suspect that they'll soon form larger and better organized groups, quite possibly internationally. The major reason that AI is attracting their attention, I suspect, is simply that AI is so much talked about now, and a lot of the framing is negative. These anti-AI activists probably genuinely believe they're doing good by stopping AI developments. Personally, I see this completely differently. More intelligence is the best thing that can happen to our planet. For the time being, maybe we should try turning society off and back on again. How special is mankind? This question threads through science like no other. Can machines learn to think? Is there life on other planets? Does the universe look the same everywhere? And how unique is planet Earth? Today I have a new paper whose authors have tackled a question most of us have never even thought about. Why does Earth have continents? And it gives a response that I found very surprising, namely, we owe them to the Milky Way. Let's have a look. Every research area has its big open questions, and for geophysicists, one of them is how the first continents on Earth formed. This matters a lot, given that we know life on Earth probably began in water and then increased in complexity once it populated land. So if you want to estimate the chance of this happening on other planets, you first need to know how likely the pleasant mix of water and land on our planet is. A few years ago, astrophysicists found that Earth is somewhat of a rarity among the potentially habitable planets. They used a computer model to study how continents and water distribute on Earth-like planets and found that those simulated planets have an 80% probability of being mostly land. Another 19% of the planets in their simulation are almost entirely covered by water. Less than 1% had a share of Earth and water like our planet does. But these scientists just assumed that continents have a certain chance starts to form by a process that most geologists believe happened. It's that the surface of planet Earth didn't cool exactly the same everywhere. Hot parts from the inside pushed up against the just formed surface irregularly and melted it again. The less heavy chemical elements basically floated to the top and later became the continental plates. But now a group of geologists at Curtin University say that this isn't what happened. They say that instead Earth's continents owe their existence to the structure of our Milky Way galaxy. They analyzed a global dataset of isotopes and ancient crystals and found that sudden changes, which indicate fresh crust production, recur roughly each 190 million years. This happens to roughly match the estimated interval at which the solar system crosses the Milky Way spiral arms. You see, Earth doesn't just go around the Sun. The Sun also goes around the center of the Milky Way, but not on an even orbit. It has an additional oscillation in and out of the plane. The authors now say that when Earth passes through the spiral arms, other solar systems and heavy clouds of gas come nearer to our solar system, and that causes more fluctuations of the gravitational field. This, so the idea, disturbs our Oort cloud. That's a shell of icy bodies which surrounds our solar system. As a consequence, Earth gets showered with plenty of comets each time it passes through the spiral arms of the Milky Way. They say that these frequent impacts caused a significant local thinning of the crust of young Earth, which seeded the first continents. This idea reminds me of Lisa Randall's theory that dark matter killed the dinosaurs. According to Randall, Earth doesn't just pass through the spiral arms of the Milky Way, but also through a disk of dark matter that's somewhat offset from that disk, and that somehow made an asteroid wipe out the dinosaurs. It's my most favorite piece of evidence for how completely bonkers people in this research area have become. But back to the geologists. If you squint at their data, you can see that actually the correlation between the spiral arm oscillation and the isotope changes isn't particularly good, so I give this an 8 out of 10 on the bullshit meter. Why am I telling you about this anyway? Because I think this study is a neat illustration for how little we know about our place in the universe and also our connection to the cosmos as a whole. In the past years, we've seen an increasing number of studies that investigate how the conditions on Earth might have been shaped by supernovae going off in our vicinity or rogue planets coming close to our solar system. Estate agents would call this a vibrant neighborhood. I find this all very interesting, not just for the sake of knowledge itself, but because I'm convinced that humans have a future as a space-traveling species, and all this information about planetary formation, about survival odds on other planets, will one day become the foundation of decisions that are much more practical than academic. Though if these geologists are right, the real estate advice is simple. Buy land, but only if your star has good spiral arm access. The origin of life on our planet and possibly elsewhere is one of the biggest remaining mysteries in science. But the origin of life is so yesterday. Today, I have a new paper from scientists who claim that life had two origins. And I want to explain why I'm optimistic that we'll indeed figure out how life began eventually. This new study comes from a group of researchers in Germany. They find that life had two origins in the sense that two of the predecessors of today's complex life had to develop the ability to independently reproduce. They start from the hypothesis that the common ancestor of all forms of life depended on minerals in hot seafloor vents to survive. This is currently the most widely accepted theory for the origin of life on Earth. The new thing is now that they say this ancestor then branched into two types of microbial life, bacteria and archaea, each of which was still dependent on the vent's minerals. And each group then separately evolved the ability to live independently without the vent's minerals. Much later, a descendant of the archaea absorbed a bacterium which became the energy-producing part of complex cells that eventually gave rise to plants, animals, and YouTubers. So this is why they say life had two origins, because these two microorganisms both had to figure out how to survive away from the vent. It's the development of an entirely self-sufficient metabolism that they call the origin of life. The researchers say they inferred this by comparing proteins from almost 1,000 modern microorganisms. I give this a 7 out of 10 on the bullshit meter because while this is an interesting study, it can't rule out the possibility that the self-sufficiency genes had a common origin, but then they mutated later in one of the branches. Basically, more work is needed. Will we ever solve this problem? Will we ever be able to say, these were the ingredients, these were the chemical reactions, the mutations that led to life? Or has it been too long ago and the evidence will forever remain vague? The origin of life is one of the topics that John Horgan discusses in his book, The End of Science. He argues that it'll remain impossible to tell different hypotheses apart. I think Horgan's wrong. I think the situation with the origin of life studies today is similar to cosmology 40 years ago, the area that studies the origin of the universe. This used to be almost entirely speculation, but since then observations have become dramatically better, from the cosmic microwave background to galaxy surveys to precise spectral measurements. And it's not just the data. Scientists also now understand much better how to extract information from the data. The result of this has not been that one day to the next we had a theory for the origin of the universe that everyone agreed on, but the details have become increasingly clear. And I think it'll be similar for the origin of life. Data will become better and hypotheses will be narrowed down. And partly I think that Horgan's wrong because the research on the origin of life is no longer just trying to reconstruct the past from fossils. Scientists have for a long time tried to reproduce the necessary chemical processes in the laboratory, and increasingly they're successful. For example, earlier this year, researchers in Cambridge reported that they found a small piece of RNA that could undergo the chemical reactions necessary for reproducing itself. Now, this molecule did not actually reproduce itself. It still needed some coaxing to get the chemistry to work out. But it's a big step forward and makes the RNA origin of life much more plausible. And scientists are trying something even more ambitious. The European Research Council is spending almost 13 million euros on a project called Mini Life, which will run until 2030. The researchers in the project want to start from elementary chemicals to create a system that maintains itself, has a boundary, reproduces, passes on information, and evolves through natural selection. It might not work, and even success would not prove that life on Earth began in the same way, but it'd demonstrate at least one complete route from chemistry to evolution, mini-life. I think they should have called it Frankencell. In any case, the origin of life has a big advantage over the origin of the universe. It's easier to create a cell in a laboratory than a universe. Thanks for watching. See you tomorrow.